Welcome to Daily Papers, the podcast where we break down the latest fascinating research. Today, we're diving into the world of healthcare and a problem that is, frankly, a bit terrifying.
It really is. We all trust our doctors to get things right, but they're only human. And the notes they write, things like diagnoses, treatment plans, and prescriptions, can sometimes contain errors.
And those errors can have huge consequences. A paper from researchers at the University of St. Andrews and Canon Medical highlights this. They cite a study in England that estimated 237 million medication errors occur every year.
Wow, that is a staggering number. And the paper says that 66 million of those are potentially clinically significant. These aren't just typos, they're mistakes that can lead to delayed or incorrect treatment, costing the UK's National Health Service nearly £100 million and contributing to over 1,700 deaths annually.
Exactly. So the big question is, can we create a safety net? Can technology help us catch these mistakes before they cause harm? The researchers think the answer is yes, and their solution involves a tool many of us are now familiar with, AI language models.
Right. We're talking about things like ChatGPT, Gemini, and so on. These large language models, or LLMs, are incredibly good at understanding and processing text. The idea is, if they can write an essay, maybe they can read a doctor's note and spot an error, like a drug that shouldn't be prescribed for a certain condition.
But there's a catch. Two big ones, actually. The first is privacy. You can't just upload sensitive patient notes to an online AI service. That's a massive data security risk. So you'd need to use smaller, open-source models that can run on a local, secure server inside the hospital.
And the second catch is that these AIs, even the giant powerful ones, aren't naturally great at this. The paper shows that out of the box, their performance on medical error detection is, well, not good enough for a hospital. They haven't been trained to be medical detectives.
So how do you make an AI better at a specific task without completely retraining it, which is incredibly expensive and time-consuming? The answer lies in something called a prompt.
A prompt is simply the instruction you give to the AI. If you give it a vague, basic prompt, like find errors in this text, you'll get a vague, basic result. But if you can write a really good prompt, you can unlock much better performance. This is called prompt engineering.
And this paper takes it a step further. Instead of having a human try to dream up the perfect set of instructions, they used an AI to write the prompt for another AI. It's like having an AI coach train an AI player.
That's a great analogy. The method they used is GPA, which stands for Genetic Pareto. It sounds complicated, but the idea is pretty clever. You have two models. The first is the inference model. This is the player. It could be a big model like GPT-5 or a smaller one that can run locally in a hospital. Its job is to actually read the medical notes and find errors.
Then you have the reflector model. This is the coach. The coach is usually a very powerful AI, like GPT-5. The process starts with the player, the inference model, being given a very basic prompt and a set of practice examples. It tries to find the errors, and of course, it makes some mistakes.
This is where the coach steps in. The reflector model looks at the player's mistakes and thinks, okay, the player got this wrong because the instructions weren't clear enough about this specific medical rule. The coach then rewrites the prompt to be better. It might add a specific example or tell the model to be more careful about a certain type of error.
The player then uses this new, improved prompt to try again. The coach watches, finds new weaknesses, and rewrites the prompt again. This cycle repeats, with the prompt evolving and getting better and better each time, a bit like survival of the fittest for instructions.
And the best part is, you can use the super powerful AI coach to create an amazing prompt for a smaller, more private AI player. Once you have that perfect set of instructions, you don't need the coach anymore. The small local model can now perform at a much higher level, all because it's been given a better game plan.
So, the million-dollar question, did it work?
It worked spectacularly. Across the board for both large and small models, this automated prompt optimization led to a huge jump in accuracy. For the top-tier GPT-5 model, its accuracy on one test set jumped by over 15 percentage points.
That's a massive improvement. And how does that compare to humans?
This is the most exciting part. The benchmark dataset they used also included the performance of 2 human experts. After optimization, the best AI model's performance was right up there with the doctors. In fact, it was more accurate than one of the 2 human experts.
Wow, it achieved state-of-the-art and became comparable to a human professional just by improving its instructions. What about the smaller, local models that could actually be used in a hospital?
They saw huge gains too. A model called QN32B went from about 58% accuracy to 69% accuracy. It's a significant leap that makes these smaller, privacy-preserving models a genuinely viable option for real-world use. The AI coach really did train the local player to be a star.
The paper also mentions an interesting detail. Before the new prompts, the models tended to see errors everywhere, flagging lots of correct notes as incorrect. They had a high false positive rate, which would be really annoying for doctors.
Exactly. The new evolved prompts fixed that. They included instructions like be conservative and acceptable practice variations are not errors. This made the AI much more discerning and balanced, reducing the number of false alarms while still catching the real mistakes.
So, what's the big takeaway here?
The takeaway is that the instructions we give to AI are incredibly important. This study shows that we can create highly effective, specialist AI tools not by building giant new models from scratch, but by cleverly crafting the prompts we use.
And it provides a practical, safe, and effective path towards building an AI safety net for healthcare, a system that can run securely inside a hospital, continuously checking for potentially harmful errors and flagging them for a human to review. It's a fantastic example of how AI can be used not to replace human experts, but to support them and make medicine safer for everyone.